Okay, ji, Assalamu alaikum. I welcome you to today's session. We are into week number 13, and today we are going to have the second lecture of this week, right? Yesterday we started off with a new topic that was polymorphism, right? We will see one more example of polymorphism today, and we'll try to conclude it today. So basically, just to give you a quick recap of what we have been looking at, right? So the main topic that we started yesterday was polymorphism, right? So as we said that it simply means the word poly means multiple or many, and it simply means forms, right? So when we say many forms, these are actually many forms of the functions. Okay, so for polymorphism, what do we need? I'll just make a list. First, you need inheritance, right? Means there is a parent class, okay, and then you have few child classes. So this is the first thing you need for polymorphism. The second thing you need is function overriding. Okay, what is function overriding? You have a function in the parent class. You provide exactly the same function in the child class, but of course you can change the body of the function, right? So the child class is saying, I don't need the function of the parent class. I will have my own implementation of this function, right? Then we also saw a new keyword which is called virtual. Okay, so any function on which you want to apply polymorphism, you will make it virtual in the parent class, right? So the keyword virtual is only in the parent class, right? And in the child classes, you will be overriding that function. Okay, so this is what you need from the perspective of classes. Now, from the perspective of main, what we do, we need a pointer to parent class. Right, it can be one pointer, it can be an array of pointers as we had seen in examples, but it will always be like that, that in the main you will need a pointer to the parent class, and you will create objects of child classes. So the pointer is of the parent class, you create objects of child classes, and you copy these addresses in this pointer, right? And then you will call functions using pointer. Right, so if you remember, yesterday we had made shape class. We'll continue with that, but if just to give you a quick recap, when you are doing, okay, so we are calling the function with pointer, and whatever address is in P, right? Because P is the pointer of parent class, so it can contain address of any of the child, C1 or C2 or C3, whatever you have, right? So when you make area function virtual in the parent class, this statement will see what is the address in P. If the address is of C1, it will call area of C1. If the address is of C2, it will call area of C2, and so on, right? So this is basically, you can say these are the key ingredients that you need when you are doing polymorphism. You need to do inheritance, you need to have a parent class and few child classes, you need to do function overriding. Whatever function you are overriding, you need to make it virtual only in the parent class, okay, not in the child class. So in the main, you always take pointer to the parent class, you will be creating objects of the child classes, right? And then you will be calling functions through pointers, right? So this was basically the whole idea, right? And we'll continue this discussion, but today I'll not make the complete class that we made yesterday. I will make only one function, right? Because towards the end of the lecture, I told you that there is something which is called an abstract class, right? An abstract class is a class in which you cannot make an object, right? And why do we want to make a class abstract? We discussed it in the last few minutes of yesterday's lecture, that if you remember, I had given you example of account class, right? That if account is the parent class and you have two child classes, right, like saving and current. So whenever a customer will come to you to open an account, you will either make an object of saving class or current or current account class. You will never make an object of account class, right? So this class actually exists because you want to reuse the common attributes and common functions which are in both these accounts, right? This class is not meant for object creation. So in some cases, we can ensure that objects are not created by making this an abstract class, right? Today we'll see how we can make an abstract class, and I think the same is true for shape as well. Whenever you have shape class, you will not create objects of shape class, but rather an actual shape like a rectangle or a circle or a triangle, right? Let me write a brief version of the class that we were doing today, yesterday. Without all those functions, I'll just make one function. Okay, so it is class shape. Okay, and maybe we have just one function, one virtual function, which we call area. Okay, and I have left its body empty. Okay, and then if you remember, we had a class like circle derived from shape, and within this class we can override this function and we can provide the implementation of area function, right? So you see now in the child class we are not using the keyword virtual. The keyword virtual is used only in the parent class. And here you can write return, of course it will have some radius, so return, you will write that formula, okay, pi r square, and then like this. So you can actually fill it. I'm not writing the complete formula. Similarly for rectangle, you will have again a public function, okay, which is area, so you can write return length into width. Okay, so this is, you can say, a smaller version of the classes that we were writing yesterday, right? But I have since we need to discuss something else, so I have not written other functions. Okay, so now when you are in the main, you see, as we discussed, you will be taking, say, pointer to shape, which is your parent class. Okay, and then you can write p is new rectangle or new circle or whatever you want, and then you can call this function p arrow area. Okay. Now you see, this area function will never be called. Okay, because every time you will either create object of a circle or rectangle, but we need to make this area function, because if we don't make it in the parent class, we cannot do polymorphism, right? But you see, its body actually is meaningless. Okay, you see, because what should we write here? Because the shape, unless we know what shape it is, we cannot compute area, right? If I ask you, okay, what is the area of shape, you cannot tell me the answer, because first you need to know whether it's a circle or a rectangle or a square, so that you can use the appropriate formula and compute the area. So you cannot compute area of just a shape. You can only compute if you know if it's a circle or a rectangle or so on, right? So basically, what we can do is we can get rid of this body, okay? And what we do is there's a syntax that I'll be writing, okay? So we put this assignment operator, right? This is not assigning, this is just a syntax. We put a 0 here and a semicolon, right? Now what is this? Now this is something which we call a pure virtual function. Okay, we have already seen what are virtual functions. Okay, but virtual functions have a body. In pure virtual functions, although you can give body, but there's no need to give a body. Then the syntax is that you, after the function prototype, you put this operator assignment and you put 0 and semicolon. Okay, this is just a syntax. Don't think that this 0 is copied in this, right? Because 0 is an integer, we copy it an integer, but on the left side we have a function. Okay, so this is not copying something, this is just a syntax, right? So if you are using this syntax, so this is called a pure virtual function, right? And the important thing is, any class which has a pure virtual function is called an abstract class. Now what will happen now? If I write this, it is a pure virtual function. This pure virtual function in which class? Shape. So now shape has become an abstract class. It means if someone tries to make an object of this class like shape S, this will not compile. It will give an error. Why it will give an error? Because any class which has a pure virtual function, even if a single pure virtual function, right? Maybe there are other functions which are regular functions or pure virtual function, but if a class has one pure virtual function, it will become an abstract class. And if some class is an abstract class, then you cannot make an object. You can take pointer, right? Which we are doing here. This is okay. This is legal. This will work perfectly fine. But if you try to make an object of this class, then this will not work, right? To shape S, this would not be allowed. Now you have made this class an abstract class. Okay, now there's another advantage of this, right? You see, when you add a pure virtual function in the parent class, you are actually making sure that anyone who makes a child class, they must override this function. Okay, because we saw yesterday that it is possible that there is a virtual function in the parent class, child class is being written by someone else. So what if they do not override it, right? So in that case, the program will still work. But now if you want to take a guarantee that anyone who makes a child class of shape must override this function, right? Now you have a guarantee. Why you have a guarantee? That suppose this is circle class, someone is writing and they do not make this function. Okay, they do not override this function, so circle class does not have an area function. Now what will happen? Since this class does not have an area function, so the area function from the parent will come here, right? Means this whole thing comes in the circle class, because circle class you have eliminated this area function. Now what will happen when you copy whole of this in the circle class? Now circle class also has a pure virtual function, right, which it got from its parent. So the disadvantage would be that now circle will also become an abstract class because it will have a pure virtual function. So you will not be able to create an object of circle class as well, right? So now you see, when you make an abstract class, you are taking sort of a guarantee that anyone who will make a child class, they must override this area function. Means if they don't override it, then their own class will also become an abstract class. They will not be able to make an object, and if you are not able to make an object of a class, then of course you will not be able to use it in the main, right? So this is the advantage of an of pure virtual function. So let me show you the same example in the slides. We did it yesterday, but now instead of with virtual function, we'll be doing it with pure virtual function. Okay, so that you get the idea, and then maybe we can discuss this example. Let me first show you and then I take your queries. Okay, so let's get back to our PPT. Okay, so you see, this is a shape class. We did it yesterday, but the new part is this thing, okay, which you see here. Yesterday, we provided the bodies of this function and the bodies were like empty, but now we have made these three functions and we have made them pure virtual functions, right? So these are pure virtual functions. And there are three of them. Now, if since shape is an abstract class, so we agree that in the main, if someone tries to write shape S, that will not work. The program will not compile. Why? It will say it is an abstract class and you cannot make an object of an abstract class. Okay. Now, the second impact of this is that when we will make a child class of shape, right? For example, if shape is a parent class, we make some child class, say rectangle. Now this class must have all of these three functions. Means this class must override area, parameter, and input. So it means now you are taking a guarantee that anyone who will make a child class of shape, they must have area function, they must have parameter function, they must have input function. If they don't do it, what will happen? For example, if there is no input function in the rectangle class, this will be copied or this will be inherited, and the rectangle class will also become an abstract class, so you will not be able to make an object, right? So this is the advantage. Now let's see how we implement these classes. So this is, I think, the same that you had seen yesterday, but the only difference is that now instead of virtual functions, we are using pure virtual function. Okay, so these are the two data members, length and width, and this is your constructor. This is the area function, the parameter function, and the input function. Now you see area, parameter input. We have overridden all three functions, right? So it means that now the rectangle class is not an abstract class, so we can make an object of this class. Similarly, we see the other example, which is a circle class. Okay, so in circle class again, we need to make sure that whatever functions you make, we don't care, but minimum at the minimum, you must have these three functions, right? Because if you don't, then if any of these functions is missing, then circle class will become an abstract class and you would not be able to make objects for this class. Okay, so you see we have implemented the area function, the parameter function, and the input function. Now this was the main we had written yesterday. Okay, it's I think exactly the same, that we take an array of pointers to the parent class. Okay, then we ask the user whether they want to make an object of circle or rectangle. If they type C, we create a circle, otherwise we create a rectangle. Then we call the input function, right? And it's a do while loop, so we keep on doing it as many times as the user wants it. And once the user has completed entering the data, we can actually display the area and parameter of all the objects, right? So we call this p of I area, p of I, sorry, this is parameter, not area. Okay, you can actually correct this one. This is area, this is parameter function. Okay, so now you see we can simply call these functions, and now we don't need to care whether it's an area or parameter of a rectangle or a circle. Whatever address is contained in p of I, right? When we created the object, that particular function will be called, right? So the difference from the yesterday's example was that instead of keeping them only virtual function, now we have made them pure virtual functions. Okay, which is like making sure that anyone who makes a child class of shape, they must override all of these three functions. Okay, so if a class has many functions and even one of them is pure virtual, then class will become an abstract class. Okay, so this was one extended example from yesterday. Now maybe we can discuss, if you have queries, we can discuss and then we continue. Okay, now let's do one more example of polymorphism. Okay, and this time we'll be not doing an example from geometry, we'll be doing an example from the scenarios, different organizations, right? So suppose we'll be making a parent class called person, right? And then we can have two child classes like student and maybe professor. Okay, so maybe every person will have a name, right? Student will have an ID, professor will have an employee ID, student will have a GPA, right? Professor will have salary and the number of books that he has published and so on, right? So we want to make some functions, right? For example, suppose we want to check whether a student is outstanding or not, right? Whether it's he or she is a good student or not. So how do we check? Maybe in the given scenario, we check the GPA, right? If the GPA is greater than say 3, so we say that the performance of the student is fine. Okay, so it's an outstanding student. But when you talk of this, so the definition of outstanding is different. Okay, if you want to check whether a faculty is outstanding, so maybe you will consider how many publications or books they have. For example, if someone has more than 100 books or publications, then that he or she is an outstanding instructor, right? So we want to check for both of these, right? But you see the definition is different, because for a student we have a different definition of being outstanding, and for a faculty we have a different definition. And it is the same thing which we had with area. You see, the formula of area is different for every shape. For a circle it's different, for a rectangle it's different, and so on. So here we are doing almost the same thing, right? But now instead of computing something, we are comparing something, right? So we'll have a function that will tell us whether the person is outstanding or not. So this is the general idea. Now let me write this program on the compiler so that we can run it and we can convince ourselves that this actually works. Okay, so I'll be making some classes. Let me check if it works. Let me just run this blank program to make sure that it is working fine. Yes, okay, it's fine. So now let's make our classes. Okay, so first we'll make the person class. And within the person class, since we are doing inheritance, so I'm taking it protected, okay? And we can take maybe string name, okay? Because every person will have a name. So I take name as a data member. Then in the public, what we do, maybe we can take an input function. Okay, and we write cout enter name, and user is able to type the name, okay? And then we can have a print function, and within this function we can ask cout. We can simply print the name of this function, okay? Just like we have a display function in every class. Okay, now you see in this class, presently we have an input function and a print function, but we don't have a virtual function as yet, right? So what we'll do is we will make two pure virtual function in this class, okay? One we call virtual void read. Why we are making this read will be like an input function, but we will override it in each of the child classes. So what will happen is that for each of the child class, since for the student we'll need to input the GPA and for the professor we need to input something else. So that's why it is like the input function that we made in the shape class, right? If you remember that if it's a circle, input is radius. If it's a rectangle, input is length and width, right? So that's why we make it virtual. And then we make another virtual function which is returning bool. We call this function is outstanding. Okay, so you see, is outstanding is basically telling us whether the person is outstanding or not, right? So for each of the child classes, it will have a different definition. Now you see, since this class has two regular function and two pure virtual functions, so in the main, I cannot do this now. If you try to do this person P, it will give you an error, right? It will say because I'm not writing on Visual Studio, so you cannot see the error highlighted, right? But if you compile it, it will give you an error that you cannot create an object of abstract class. Okay, so you can actually do this on Visual Studio and check this that now you are not allowed to make object of person class because person is now an abstract class. Okay. Anyways, now we come here and we make the child classes. Okay. So the first child class that we make is student. Okay, so this is the student class. Now in student class, what do we need as data? Maybe we need the GPA of a student, right? So we write private float C GPA, right? And within the public, now you see what we need to do. Since student is the child class, okay, sorry, let me correct the spelling. Student, yeah. So it is child class of person, and person class has two pure virtual function. Now student class must override read function and is outstanding function. If I don't make these functions in the student class, the problem would be that they will be inherited from the parent, and student will also become an abstract class. So I will not be able to create objects of student class, which I don't want, right? So it means that in this class, I don't have a choice. I must have this function. Okay, and I also must have this function. Okay, so now since we have provided body, I'll write it as well. I'll complete it. But now student is not an abstract class because you have given the body of the function. Okay, so now you can make object of student class. Okay, now let's see what should we write in the body of this function. The read function is like an input function where we want to enter data. Okay, so a student has two attributes, GPA and name. So what you can do is you can do cout enter name, and then you can write see in name. Name is protected in the parent class, so I can access it. Okay. Similarly, enter C GPA, and here you can write C in C GPA. Okay. Now you see this statement we already have in a function which is called input in the parent class. Okay, so if you write this is perfectly fine, but you can also, if you want, you can also call the input function from here, because input is inherited from the parent. Okay, so it's your choice. Since the data is protected, you can directly write c in name within this, or if you want, you can call the input function, because you see we are already doing it in this parent class, so you don't need to repeat it here. It's only a single line, right? But if the person class had, say, 10 data members, including everything like address, phone number, then of course you would not like to repeat all those 10 cout statements here. So it would be a good idea that you can call the input function from here, right? And similarly, maybe if you want to override this outstanding function, right? So you see, for a student, first we need to say, okay, what is the definition of outstanding? We say, okay, if the CGPA of the student is greater than 3, then we return true. Okay, because we assume that the student is outstanding, otherwise we return false. Okay, so this is now, of course, you can make other functions in this class as well, but the minimum requirement is satisfied, that now we have provided the body of the read function as well as outstanding function. Okay, so of course other functions can be added, but the minimum that was required, we have done that. Now what next? Next we make another class, okay, this child class, which will be inherited from, again, person. So we call it class maybe professor. Okay, within this class, we say, okay, what are the data members of a professor? So we say integer number of publications, right? That they have done some work, they have published some articles, some books. Okay, so how many of such articles or books they have published? Okay. So now when we come to the public, again, within this class, I don't have a choice. I must have a read function. Okay, and I must have a is outstanding function. Okay, these are the two functions that I must make in this class. If I don't do that, the professor class will also become an abstract class. So in the read function, what you can do, you can write cout scene name, but as I told you, you can call the input function of the parent class, because you are already doing scene name in that function, and here you can write cout enter number of publications, and the user can enter that value. Okay, and similarly, when we want to override this function, which is outstanding, so we have a different definition than student. So we say if number of publications is greater than 100, so we say return true, something like this. Okay, so again, we have met the minimum requirements for this class. We have a read function, is outstanding function, right? Now we can go to the main. Okay, so in the main, if you want, just like yesterday, you can take an array and you can make a do while loop, right? But since we have already seen that, so I'll not be repeating it. I'll just not be using a loop. I'll just be taking an array of 2, and I'll be copying in them the addresses of 2 objects, right? But of course, you can, if you want to make a good program, you can do like yesterday, where you have a do while loop. You ask the user whether they want to create an object of professor or student, and then accordingly you create that object, right? So since we have already seen that, so what I'll be doing is I'll be directly creating object. So I'll be creating one object of, say, student. Okay, and in P1, I'll be creating an object of the other class, which is professor, right? And now what you can do is you can use a for loop. Okay, and within for loop, first you can call the read function. Okay, so now what it will do, it will call the read function. The first pointer has address of student, so it will call the read function of student. It means you will enter name and CGPA. The second will have the address of professor. Okay, so you will enter name and number of publication. And then what you can do is, once you have entered the data, you can actually call there is outstanding functions, right? So you can if you want, you can call this function like if. Okay, so we are calling this function is outstanding. If it is true, we can print the person is outstanding, else we print. Now you see, just like yesterday, I'm writing person, right? Because I don't know whether he or she is a professor or a student. It depends on what order you have created the object, right? So I cannot tell whether the function is called for professor or student. That's why I'm using the terminology person, right? So now this is one complete example, which is allowing you to enter data, and it is allowing you to check whether a person is outstanding or not. So if I give you a quick recap, we have these two pure virtual functions. By making a pure virtual function, the person is now an abstract class. It means you cannot create an object of this class, okay? And we derive two classes, student and professor. So now in each of the child classes, we have a compulsion. We must override the read function as well as the is outstanding function. If I don't override any of these functions, the disadvantage would be that the child class will also become abstract and I would not be able to create an object, right? So in the main, and just to remind you that this statement where you are calling the read function or the outstanding function, this is actually what is telling you polymorphism, which is illustration of polymorphism, right? Because you are writing pi arrow read, but the behavior of this function is different. Depending upon what address is in P, sometimes it will be calling the read function of the student, and sometimes it will be calling the read function of the professor. It will not see the data type of P, which is person. It will see what is the address in P, right? So, and the same discussion applies to the second function, which is outstanding, right? So this was, you can see, yet another example from polymorphism. So maybe now if you have some comments or queries, we can discuss those. Okay, so now I'll be just quickly giving you an example that suppose we have a class. Let's do the same example, shape, okay? And in this class, we have a virtual function uh, area. Okay, I give it some body and so on, right? And then I make a child class like we did rectangle. Okay, so what you will do, you public में होगा, ठीक है? I'm not writing public, but you can write quickly. It is public. So you will write the body of this function. Okay. Now suppose within the rectangle class, you make some additional function, like you make a function void f, and it has some body. Okay. And similarly, you have another class circle and triangle and so on. Okay. Now when you are doing polymorphism, okay, so this would be your main. Okay. Let me change the color so that it is visible. Yeah. Now you see in the main, you will take a pointer of shape class and you will write. Now you see, you can call this area function, which is okay, which it will call the area function of the rectangle, right? But now there is a limitation of polymorphism as well. What is that limitation? The limitation is that now if you try to call this function f, which is only in the child class but not in the parent class, then this will not work. Okay, so in other words, if I write this statement, then this will give me an error. It will not compile. Why it will not compile? Because you see, P is of type shape, which is the parent class, and in parent class there is no function f. Okay, so you can call all the function of the child class because they are virtual in the parent, so they will be executed for the child class. But if there is a situation in which you have some function in the child class which is not in the parent class, okay, just like here, the function f is in the child class but it is not in the parent class. So if you write p arrow f, you try to call it, it will not compile, it will give you an error, right? So you see, this is a limitation, that it means whenever you are doing polymorphism, you also, if you want to call it, you also need to put it in the parent class and you need to make it virtual. Only then you will be able to call it, right? Otherwise, if it is not present in the parent class, when you write p arrow f, since parent class does not have a function f, so this will give you an error, right? So this is something which many students miss when they are writing the program, right? Maybe in hurry or due to some reason. So please be careful about this limitation of polymorphism, that whenever you are making a child class, if there is a function which is present only in the child class and not in the parent class, then with the pointer of parent class, you will not be able to call it, right? Of course, if you make an object of rectangle, like regular rectangle r dot area, r dot f, then you can call it, okay? But of course, if you are doing that, then you are not using polymorphism. So if you use rectangle class in a conventional way where you create objects and you call functions using dot operator, you don't want polymorphism, then it's okay. But if you are using polymorphism, then all the functions that you want to call, you want to make, please make sure that you also add them to the parent class. Otherwise, you will not be able to call them when you are making a pointer to the parent class, right? So with that, it concludes our discussion on polymorphism. If you have some comments or queries, we have few minutes, we can discuss those. Thank you.